All right, so now we're getting into non-standard conditions. Remember, standard conditions always assume 1 molar concentrations. And in this case, we are not at equilibrium. So the first thing we need to try to do is identify oxidation and reduction. So this here is oxidation, this is reduction. Oxidation is the anode, reduction is the cathode. Now, again, before we deal with the rest of this, let's go ahead and get our standard cell potential. So nickel is here, negative 0.23. And this is a vanadium something, which is right here. Make sure it matches up. And okay, yes, so that's gonna be positive 1. So here we take cathode, positive 1, minus negative 0.23. So we get positive 1.23 volts. Okay, so we're gonna need that. The next thing we need to do is we need to balance our electrons. Notice they're not balanced. Okay, so to do that, we need to multiply this whole thing by 2. This one stays where it is. Okay, so I'm gonna be able to now cancel these electrons out. But, so let's go ahead, just like we would combine the redox, they're balanced by mass and everything, so now we're ready to combine them. So nickel plus VO2 plus 4H plus 2 electrons makes nickel plus 2 electrons, VO plus 2, that's a plus 2, let me just make that clear, plus 2 H2O. And this is a liquid. Okay, so these go away. Now, we're not at standard conditions, so we can't use the equilibrium constant K, but we're gonna need to use the reaction quotient Q, which is gonna be calculated in the same way as K. Remember, pure liquids don't count. Now that we know what's happening here, and we have our proper coefficients. That's why we needed to do, oh, I don't have my proper coefficients. There we go. So we're gonna do our products over our reactants. Remember, nickel is solid, so it doesn't count. If you need to write the phases in, that's fine. And H plus to the 4th. Okay, so now we know what that is. You can go ahead and plug and chug this if you want to. Here we know our cell potential is going to be our standard cell potential minus, again, I'm going to give you this equation. So here we have our standard cell potential, 1.23 volts. Minus 0.0592, that's a volt if you want to deal with it, over, we have 2 moles of electrons. And then here's where I'm going to plug in my Q. So just plug in things that you know. Nickel plus 2 is going to be 2, and VO2 that's 2 squared. Oh, there we go. Let's say I didn't get all that correct there. All right, and now Yeah, VO plus 2 there, okay. And so this is VO2 plus, which is going to be 0.01 squared, and thank goodness our hydrogen is to the 4th. So now it's just a matter of plugging and chugging. You could have done this up here if you wanted to. That's fine. I'm not going to do that. 2 times 2 squared, that's going to be 8. Divided by 0.01 squared. So that's a big number, 80,000. Let's go ahead and just take the log of it. Multiply it by 0.0592. Divide that by 2. All right, so that gives me 1.23 volts minus this answer. Oop. So my new cell potential under these non-standard conditions is positive 1.08 volts. So it is still spontaneous, but it's less spontaneous than it would have been otherwise.